good, looks good, looks good, looks good, looks good. Sounds like the audio is picking up correctly. Let's check it out on the phone. My live video. Okay, how's it sound? Checking on sound, checking on sound, checking on sound. Sounds good. Well, okay. What I'm working on is getting my big AlphaBot set up and soldered together. I actually got this on Wednesday, but I haven't had a chance to actually plug it in or do anything with it until today. So I'm looking forward to it. And should be able to get some good progress. So it is a Raspberry Pi with an Adafruit motor hat. I'm going to go ahead and solder the motor hat first. Get this together. They actually recommend, then I'll also do the motors themselves. Solder the wires on those. Now, they recommend, what I was saying earlier, to not use the terminal blocks, because Adafruit includes these where you just have the terminal blocks here and then screw your wires in on the connectors or to the connectors so that you don't need to solder them in. But with robots, since there's a lot of moving parts, actually soldering them is usually better. However, I'm going to, I ordered several of these, believe it or not, and so I'm going to actually do one with terminals and one without. Where I'll just solder it directly, but initially for the first one I'm just going to solder it with terminals. I should not need my multi-arm deal, so I'm going to hold that to the side for now. I have a little fan on the side, and then I'm going to go in here. With soldering, the fan, just to keep some airflow up, is probably most important. You don't want to breathe in the dust because it has a little bit of lead in it. There's a Raspberry Pi 3. checking to see if I need anything else before we get started. I have a Hako soldering iron here on the side. I'll pull it forward just a little bit so you guys can see it. And hopefully I won't trip a breaker, which is the biggest thing I'm worried about as it heats up. I love my Hako, it goes fast for heating up. Right. Now to solder one of these, it's easiest to take an existing Raspberry Pi 3, put the header on it, and then drop this in place on top of it. You can use one of these guys underneath it on the opposite side to give it a little bit of support. Not that I want to hold it up or anything, but it just gives it a little bit of support on the opposite side, so you can solder this evenly on this side. Find the end of my solder. In the end just a little bit. Ooh, you guys want to be closer? Alright, prepare for zoom in. Oh yeah. Actually, before I get too far along, where are my glasses? One of the reasons you wear glasses or some kind of eye protection while doing this is that the solder can bubble up from the solder core and get in your eyeballs, and just micro pieces. But it's one of those things where it's better not to have micro pieces of solder in your eyeballs. So, safety goggles. Of course, these are my sculpting goggles, so they're kind of overkill, but they'll work for this easily. Alright, I'm trying to see where everything's at on the screen here. There we go. Alright, perfect. Alright, anyway. Tin the end just a little bit. First one in, let it cool a little bit, and boom. That should be enough to get them all going. Of course, now I've got to, I want to make sure you guys can see it. Make sure I can see it. I think my light is probably just a little bit off. Yeah. This is never quite easy. Go. Once you get going at it, though, it goes really quick. The biggest problem I run into, the fan, well, cooling things off makes it so that you lose a little bit of heat too. And camera wiggle. Alright, light has got to be better. very, very nice. I'd love to have one of those macro cameras so I could actually show this to you guys up close. Alright, one half done. Of course, what I'm doing is approaching it from the side. Yeah. Sorry for the camera wiggle. Okay. Oh, really? Come on. Conduct heat. Yeah, when it's working properly, the solder just it's sucked right down into the hole in the board. You kind of want to put the soldering iron tip on the pad, the copper pad on the circuit board, on the PCB, and touch it so that it's touching the post sticking through the PCB. And then your solder itself, the solder wire that you're adding to the system, you want to touch the other side of the post opposite the soldering iron. And the reason for that is the post itself is supposed to get heated up, which means it and the pad are almost at the same temperature, and the solder will flow from the post into the pad hole. It'll give you a really good solid connection. Of course, now we're getting down and dirty with the soldering. Alright, so it looks good. What I do at this point too is kind of hold it in front of the light and check for solder bridges, like where it might have gone between two posts. But I don't see anything like that. So it looks good. Cleaning my soldering iron on the brass, and we can pull the board off of our Raspberry Pi and get our mount out of it. And there we go. So now we're going to do the other side, which is a little bit harder. Because in this case we're soldering onto these mounts, which means we've got to solder from this side, and there's not necessarily any support, so I'll probably end up doing something like this. Alright, so I've got the 5 and 10 volts. Should be one more of these. So it's a block of 3 and a block of 2. And a block of 3 and a block of 2. Also, you can barely see it, but on each of these there's a little notch that sticks out. That's how they line up, and so what you can do is actually slide the two, or actually no, these guys snap together, I guess. snap the pieces together so you get a solid terminal block instead of 2 in one and 5 in the other, or 3 in the other, excuse me. There we go. Like I say, it's kind of hard to see, but it's there. And it gives them some support too. It's not needed, but it makes it nice. And slide them together. There we go. Very cool, very, very cool. Helps if you put it all the right way. I use mine facing outward. Gives me more space. Makes it so that it won't fall out if there are problems. Looks like I'm going to have to move the camera unless you guys like the wiggle cam. Notice these terminal blocks are also a lot thicker, and so they're going to take a little bit longer to heat up. And these are probably going to end up a little wonky because I'm not exactly flat. I can actually see the fact that they're pointing one direction on the board there. So, well, at least the first batch is going to stick out a little bit, but I'm okay with that. I'm not going for sexy, I'm going for functioning. Ouch. I can feel the solder. Speaking of heating up, I can feel little bits of it heating up and hitting my fingers as I'm soldering it. Yeah, this is the fun stuff. So this is going to be for a Let's Robot streaming robot. I should say that. Look at that. Very nice. Very, very nice. Other than the fact that that one's a little bit wonky, but oh well. Success. Well, at least part one of success. So this will just mash on this board. There's actually a different board that I'm going to use for this. So normally these can be used for stepper motors as well as regular RC motors. The outer pins are positives, the center ones are grounds. You can actually, there's tutorials on Adafruit's website. And I'm only going to have one, so I didn't install a stacking header. This is a prototype though, so I might actually be using some of the PCB board. Or they include like a little mini breadboard here. So next I'm going to start soldering the motors. So with the kit, they actually included a giant spool of wire, which is great, or bundle of wire, and all the motors. And one of the things to notice about the motors is they are actually polarity aligned. So you can see some of them will have a red dot. In this case, there's a faint plus embedded there. So I want to keep my wires to match red and black for the polarity so that I'm sure of what it is. Now, I'm not sure. So the case itself, pull this out, looks like this. Go back to wide angle cam for just a little bit. Whoa, this my clip's about to fall off. And the motors will sit inside here. Let's align it. And so they've got to reach from wherever they're at to the Raspberry Pi. Now the Raspberry Pi itself is also going to have a microphone on it. So I think I want to And actually, this is the back, this is the front. I think I want to be able to reach up here because there's a cover that goes on top, but if the Raspberry Pi is inside, it's going to pick up a lot of the noise from the motor, so I want the Raspberry Pi outside. So I want them to at least, the wiring to go at least the length of the thing up and probably as far back, just to give me more than enough slack. So, handy dandy nippers. And then what I'm going to do is have the battery actually sit in here on top of the motors as well, and I'm going to add some padding to help kind of cut some of the noise out. So, anyway, this is the voltage converter, and it'll actually sit at the back here. The voltage inverter, and provide the power to the Raspberry Pi from the battery pack and power to the motors. So it also is. This is going to be the limitation of it, because it's got to reach, this is going to be the motor power, so it's got to be able to at least reach that far. So the motors have to at least reach that far as well in their wiring. All right, I just spent way too long describing wiring, but think about it now so you don't have to think about it later. And also, if you need to trim some off, that makes it easier too if you've got extra. Motors, 4 wires. Looks good. Pop this on the side. Pull the motor back out. These will get bolted in when they're ready, so. One of the things about soldering wires, and these are stranded wires, so you want to do something called tinning the wire. Excuse me, where you actually put a little bit of solder on the end of each wire, and the reason for that is that it allows you to a convenient holder. Solder sticks to solder really well. Excuse me, back to tinning the wire. So as long as we've got a little bit of solder on the end of the wire, it should help it stick to itself, which will make soldering it a little bit easier. And there's little holes, you can kind of see, on the ends of the terminals there on the blocks, so we can be able to trim those, or just loop it around those as well. Gives it stronger connection, easier flow when we actually solder it. So, and we'll want to do it on the other side. Drop one of my wires. I really should have a face cam on this as well. Anyway, so I strip off a little. Twist the ends to give it a little bit of extra strength. Well, actually, this gives it rigidity, it doesn't give it any strength. Just makes it a little bit easier to work with. The gentle hum of CPUs in the background. Alright. I would say that this rather boring part is done, except we now have to do the other ends the same way. I could be super cool and try and get all my wires the same length, but I'm not, and I'm not that worried about it, so. On this end, these guys will connect to the motor hat that's going to go on the Raspberry Pi, so all they need to be is tinned, and they'll be attached to the terminal block. Now you do want to keep these, once I tin them, I'll actually probably trim them down just a little bit, because they don't need to be as long as I'm at this length. Maybe they should be just a little bit shorter. So the flexibility of having just a little bit longer wire here too means that if you're going to move your Raspberry Pi or have it fixed on a movable mount or a hand tilt, gives you a little bit more distance and flexibility as to where your placement is. One. I'd probably get more people chatting if I weren't doing it at midnight. Yeah, it's midnight here. So all my viewers in the middle of the Pacific Ocean are watching this on YouTube. Not really. My goggles. That's why I'm doing when I'm touching the end of the thing there, is I'm tinning the end of the soldering iron itself. And just a little bit of solder down the tip of the wire. You can kind of see it. It gives it a little bit more. Now this part will give it solidity and the idea that, you know, you can, or, meh. I already explained it, I'm not explaining it again. That's enough explanation. No more! Alright, this part would help if I had the third hand up here. Alright. Moving some junk, getting third hand. Quiet you. I'm streaming at an awesome 1280 by 724. I actually find tinning the wire is the hard part for me. I never know exactly when is right. test, I guess. You know it's working properly when you touch the wire and the wire itself absorbs or melts the solder. You're not touching the soldering iron. That's what you want. So, clear up some crap here. I clean my soldering iron between each round of whenever I put it down, simply because the solder itself oxidizes so fast. Or I don't know if it's oxidation or what, actually. That's a good question. You know what you don't want is giant blobs of solder. That's what you're trying to avoid. In the end. One of the nice things about stranded wire is that it will absorb the solder, or it didn't absorb the solder. What I mean is the capillary action pulls the solder in, and it actually pulls it between the strands of the wire really nicely. A little bit too fast on this one. Good. Partially done, or two fully done, excuse me. Last two, and then we can actually solder them to the motors. I'm only doing 4 at a time. It's just because for ease. It's not for any specific reason. I think my biggest problem is I'm impatient. I touch the soldering iron to the wire and I want it to start going automatically. I'm like, why isn't it going already? blob of solder on the end of this one. There we go. Normally you use something called solder wick to pull that out and get that away. Alright, now onto the motors themselves. And of course, now that the ends are a little bit hard, they're a little bit harder to bend. Some very fine needle nose pliers just for this occasion. Alright. A bit of solder on the tip of my thing. The big issue is making sure that I don't lose the stability, so I'm actually going to press from the side and kind of hold it in place. Because now I'm heating up both the wire, the post, everything. And I'm going to go for a good old lot of solder on there. Perfect. There we go. Alright, looks good. Give it a second. Ta-da! One battery. Successfully soldered. Or, I'm going to say battery. One motor successfully soldered. Me to get like Monster Cat streaming or something, because talking through this whole thing is good and all, but I'd like to listen to some music too and do one of their streaming plans. I know it's Canadian techno and all, but you know, hey. Alright. Red wire connected to the positive terminal. Oops. A little bit of solder on the end of my soldering iron. Blob. I'm less concerned about massive blobs of solder on these guys because make sure that it's all attached. So. I'll say it is very easy to burn yourself with this because It's a soldering iron. It's hot. You're touching it, or you're close to touching it. And it's very easy to burn the living crap out of yourself. Happy little solder. Ouch. You might think, well, why don't you just clip all the wires on there before you get started? Hey, my post is bent down. Mainly because if they fall out, then it kind of sucks. And since I'm doing it each one individually, there's no real reason to. Looking over at my viewer count at 0, so it's like stream like nobody's watching. Which I think is a Penny Arcade t-shirt. Not that electronics is a huge following. In the live streaming world. Looks good, looks good. Alright. Successful. Am I going to solder anything else? Well, what I would like to do is go ahead and tin the ends of these wires. So these are the wires that are going to be used for the in the motor hat. It has a 5-volt source for providing power to the motors themselves, or it has terminal poles for that. So what I'm going to do is I want to tin the ends of these wires so that they'll plug into that easier. Stranded wire has a problem, whereas if you push on it or provide any force to the end, all the strands will like fray. So just a little bit of solder should help that. And then we should start putting things together. thing came with a ton of screws, which is fantastic. But what it didn't come with is information on which one is the importance, or the ones that you need. So I think these M3 screws are the ones that will go through the case here. Well, I think they're too short. They're way too short for that. It's either going to be these guys or those guys. So I'll tell you in 2 seconds. It is not those guys. It's probably these guys. Yep. Alright. Perfect. Oh, really? Some of the holes don't match up exactly, so. Alright, let me stop propping my screws up on my pliers. And I should have put washers on these. Really? Alright, that was just gross. I'll fess up, that was gross. I don't often use my nose to hold up my screwdriver, but you know, when it has to happen, it has to happen. Let's see, I've got 4 motors. 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 13. So 13 of those screws. So let's do 3 per wheel. Not ideal, but it'll work. slightly easier to slide the washers on first. That way you're not trying to do it each and every time. Not a huge deal. There we go. So this one here is very difficult to turn. Alright, so the other ones were fine, so I wonder if there's something different about that hole. If it's shallow or something like that compared to the other ones. Yep, and it actually is shallower than the other ones. I might back that one off on the other side then. Go into your hole. Adventures of me getting screws wrong. Fuck a duck. holes don't line up exactly right, so it's kind of like oh, man overboard. Oh well. Luckily there were 13 screws, so as long as we don't lose anybody else. Yeah, I think I'd warped the end of that screw because screwing it in here worked just fine. So, and pulling it out of the hole that was resisting it was difficult as well. So I think that's what happened. Alright. And the other side. If I were really super cool, I could have put some heat shrink wrapping on the end pieces so that I could have wrapped them while they were to ensure that they don't touch, but they're far enough away. And if needed, I would just put electrical tape on it, I think. Getting my screws prepped. Not the most exciting stuff in the world. So I think one of the things that I did wrong was I didn't leave it loose enough when I was bolting it in the first time, and so it when I tried to add, so on the second wheel I screwed in the first screw very tight, and so it made it so that the other screws didn't have flexibility to kind of rotate where they needed, or rotate the motor where they needed to make the holes line up better. So word. of these are going in fantastically. Fantastically. I guess as I'm sitting here tightening it, I can feel it tightening back here under my hand. I should apply, like when you tighten the lug nuts on a tire or on a wheel, you want to do them kind of in a star pattern so that it evens out the pressure. I think I should probably do the same on these guys. They are in. Alright, perfect. Multiple 1.5 wires. Great. So that's done. The things I want to attach next are, so here's the camera board that'll be part of it. And it will be in here. So let's use, I'm betting it's going to be these guys. Yep. And they're super long though. I wonder if we can use these guys instead. Nope. These guys it is. Unplug that for now. So this on the back side. Oh, too bad I can't have it up front. The washers, they're not small enough. The baggy's not small enough, Jesus. Alright, let's watch as I fight with a bag. Oh, look, a solution presents itself. I'm debating whether to do all four all the way around this thing or to leave it more loose. But I'll do all four. This one I'll definitely not crank down on because I'm basically applying the pressure right to the board. I'm doing washers on this side, but also do washers underneath the nuts on the back. They go into the board. super fine screwdrivers. There we go. And we lost one. Magnetic screwdrivers for the win. Good. Awesome. Everything is awesome. Everything is cool when you're part of the team. Everything is awesome. I keep going, but you know, I don't want a content ID flag for the Lego movie. So, no. Speaking of content ID flags. Somebody once told me the world is going to show me. I guess roll me? Maybe roll me. Alright, camera board secure. Undo the wire for now as it is, but coil it up later. And it's ready. Stringy stuff. Alright. So now on the back side here is where the inverter goes. And I'm going to do this on the inside, and I'm going to actually do it upside down. The reason for that is this is where my cables go. You can do it at the bottom, but then to try and get to them, I'm going underneath it. So that's it. That should work. Yep. So this is going to be these guys. There's the thick ones. Nope, it's the thinner ones. All right. Never mind. Good. These hex nuts. Great. I said inverter. I guess it's a converter. It actually sits much further down in the thing than I thought. The holes are made to fit the bottom slots, not these guys, and I thought they were. Yeah, so it's this width, not this width. Which is fine either way. Fine for me either way. Or not. Why is this one not? .3D printing. There's no actual threading on this. It's just a really tight fit. There we go. Boy. Stand this up on end. Put the washers and the initial screws on. Excuse me, bolts. Nuts, I guess. Oh, nuts. Nuts. Maybe, just maybe. I should get an electric screwdriver. Getting things out of the way. Nice. Okay. Awesome. Everything is fine. I'm going for content ID, striking started videos. Everything is awesome. Okay. This plugs into the battery pack, so it needs to stay down. And this one is for the Raspberry Pi motor hat. This one is for the Raspberry Pi itself. Motor wire, motor wire, motor wire. Alright. So the battery that came with the big time Alphabot is this bad boy here, which is just fantastic. So it should fit right in there. Plop. It crushes all the wires. Oops. So should route the wires underneath it properly so they come out this gap. Well, they gave me a power switch, but I'm not sure where to solder it into the system. Whether it should go to this guy or across here. It's like, where is the intent that it goes? You know. Or if this is even supposed to go in here and out, sit on top of it. So there's a lid. That's this guy. Bolts or six. Excuse me. Right on top here. Obviously it's told to be able to reach the battery internally. That's quite hefty. So I'm not going to plug in the battery yet, although both of the cables are now available. So I'll tuck this guy under a little bit. You know what I didn't do? I didn't label the wires to which wire went to which motor. We'll never know. Not really. I'm gonna find out. I'm gonna find out now. I ain't waiting. I had a friend who was going to ask to help build this, but he wasn't able to make it. So. Alright, so we got one. We'll do one knot in. And we got two. We'll do two knots in. Keeping it even where the odd side's odd. So this will be 3. And this will be 4. Perfect. Still perfect. I'm routing the wires up in this gap beside the converter, because the battery power coming out of this guy is huge, and the converters needed to do that 12 to 5 volt conversion for the Raspberry Pi. And this also has a huge amount of current, which the newer Pi 3s really need. Okay. Looks good, looks good. Looks good. There's one other bag of screws that I believe. And screws to hold the lid on. These are all super long washers, or lock nuts. But I'm actually probably not going to put these on here. I am probably not done tinkering with it, so there's no need to seal it up yet as I drop one of the bolts and go on the floor. So I'm going to hold off on that until I'm really ready. In the meantime, though, I'm going to put on the wheels. So these are the wheels, 3D printed. Big lock nut. There's a flat side on all of the motors. So we'll torque these guys down. Come on. Wow, it's 2 in the morning already. Alright, well, we probably won't finish this tonight then. Well, what I'm going to do is, actually, screw it. The only thing I have to do tomorrow is like move my wife's studio. She's an artist and has an art studio. Known about it for weeks and just had to get the car for it tonight. The van, excuse me. And the tolerance of one does it really tight. 2 wheels on. It's starting to look like a motorized vehicle. Yes, yes, yes. Awesome. Everything is awesome. I'm doing it again. Everything is going for a copyright strike. Everything is cool when you're part of a lawsuit. Everything is awesome. What is it, Python? Introducing Python the cat. I guess, you know what I should have done? Flip this over and actually done it on its top. And that would have made it easier. All right. Baby kitty. What is it, Python? Alright, now, so I've already had the Raspberry Pi set up. I got it over here running top. So let's pull it off. And I've also set it to a fixed IP address of 168.1.235. I've got a cat attached to a KVM, so. Alright. Perfect. Yeah. So it was incredibly easy for me to debug it and set it up with all of the Let's Robot stuff. So now I've got my additional thing I got for this particular project. It's a set of standoffs, Adafruit for the board. So actually, so with the big Alphabot, they actually put this piece of fabric tape over it to keep it from the underside of the board from contacting the basically hitting the components on top here. But so since I like that same thing, I'm going to Just add them there. I'm okay with a little extra stability on this. Which is exactly what it's for, the stability. Now I can do this. There we go. Perfect. And we're almost ready. So this is the microphone. So I'd like it up here. So what I'm going to do is actually a couple of things. Because I've got to route all the wires up here, power included. And notice this guy's going to rattle around a little bit. So nice large sheet of foam I saved just for this reason. I'm going to put it underneath it. To give it some stability. See my hardcore cutting system here. Nice X-Acto knife. There we go. No, actually I should probably get like an extension, USB extension cable for that so that it comes out to the front. But for now, alright. Now we're actually really glad I gave extra distance to my wires because they are almost out the front here. Might do is put just use electrical tape on these guys. Or painter's tape to hold them down. Micro screwdriver sets. Activate. Okay, cool. Alright, so this was one. Positive on the outside, ground on the inside. And I'm going to trim these down just a hair. Because all of the wires will be pulling back, I don't want them the next set of wires coming back against these guys, shorting them. Perfect. That very, very close, very, very nice. That's one. There's two. Be careful when you're trimming the wires too, just in general, because what can happen is you're applying a lot of force on that end of the wire, and so it'll just come shooting off. It's easy to get hurt by it. Just a safety thing. Yeah, so really I should be wearing safety goggles when I'm doing that, but I'm also keeping pressure on the end of the wire. And this one's 3. So I'm matching the M1, M2, M3, M4 on the top of the motor hat. Star Trek battle music up in here. Not really. I wouldn't have started so late, except I fell asleep late tonight and then woke up. I was like, okay, I want to get started. I want to do this. I want to get it done. I want to record this video so I get it done. Okay, awesome. So let me hook up the motor power cables. Turn these down a little bit as well. So this guy is, what do we got? This is power for the Raspberry Pi. This guy's the camera module. And let me route it this way. Plug it in there. The speaker is here. Actually, no, route that way. Do that whole thing through there. Alright, now that I've got the board kind of where I know kind of where I want it and where I want the cables to go, I'm going to start cable wrapping. And I use tie wraps. They're zip ties. Giant bin of them for like $10. Yeah, as Little John would say. Yeah. Awesome. Everything is awesome. Everything is heading for a copyright strike. There we go. And some painter's tape to hold down the board. That's really temporary. So what I'm going to do now, besides clean up a little bit of the mess here, so this is the speaker that allows people to talk to me through Let's Robot. I want it up here. I should stick it right there for all intents and purposes. Now the reason I'm thinking over here is because then I can just tie wrap it to the holes that are in the side of the box, which I might do. Do it on this side instead of that side. Same press. Beautiful. Are you doing okay? I'm still working. reserved a car for us.
What you got?
What is it, van? Here, we'll take the trolley down in the morning.
Okay.
Maybe I should have put bolts in that.
What python?
Oh, boy. Alright, that sucks. Alright. I might hot glue that later.
I love you.
I love you too.
I'll stay up too late.
I didn't realize it was 2 until like 10 minutes ago. So I realize now that I've been talking through all this and have been focused on the Raspberry Pi connection screen, which is now kind of blank. So, oops. It makes for very boring streaming. Because, you know, now you haven't seen the work that I've done in the past 10 minutes. So, speaker, the webcam cable, routed it through, used zip ties, a couple of pieces of foam underneath it to not hopefully deaden some of the vibrations from the box into the board, because there's a little microphone here to pick up the audio. Routed my cables, tied them down. A little bit of zip tie action everywhere. I always come down just a little, maybe. And be careful, because this also trimming down your zip ties can leave really sharp edges. So. Helps to burnish them, which is just beat the shit out of them. So beat the devil out of it. There we go. Sounds good. Sounds good. Let's give power to the Pi. Oh, let's see, power lights on the Pi. We're booting up. Yes. Awesome. So, I put a fixed address in. And we have that. So I'm actually going to set it on the floor for now. And go to the Let's Robot website and do the setup. So, hold on a moment while I put away some stuff. I'll take us all there. I'll probably go back and redo the part of the video where I had you guys staring at the screen for no reason for 2 hours. Or not 2 hours, I'm exaggerating. For more than it should have been. So. Yeah, I'm very excited. active. Let's see if we can restart. Yes. Awesome. Somebody else's robot. Let me go into mine. Connect your robot. That's what I was looking for. Now, I don't know if the robot ID is supposed to be a secret or not. Let's call this one. So this is large. We're going to call this one Elsa bot. Alright, I've already installed all of the bits. Alright. Cat start robot. Alright. Oops. Ugh. Let me set up my terminal correctly. I thought they set this for English already, but screw you. 3, 4, 6. And did it again. All right. Oh, it's fantastic. It's working. So let me do that. And I'll go up full screen. Alright, so I'm heading back. Oh, my cat doesn't know what to think about this. Oh, oh, I can see it. Yes. Test. All right, so I got to get the wheels fixed. Manage my robot, Salsabot. Okay. Alright, Elsa block. You're probably going to have to go up on blocks for a moment. So Python doesn't know what to think of it. She's okay with Elsabot, but he's a bit unsure. Oh, yeah. The novelty is worn off and she walked away. So the entire screen's kind of yellow too, what I'm noticing. So in the actual video stream. So I have to work on that, see what FFmpeg is doing. And I don't know. Alright, well, that's probably enough for tonight because I'm not going to go debugging motors at 2:38 in the morning. I'm very happy to have gotten as far as I did, though. See you all later. Yeah, this is Donco signing off. Woot woot.